Hello and welcome to the second episode of our state machine tutorial series. In this episode we will expand our state machine a bit by adding collision detection and the jump state. So the first thing we want to do is to improve our player movement script by adding the player rotation in it. So basically rotate the player in the direction we are moving or that we are actually facing while moving. And for the visualization of that, we want to add some eyes on our player. So the first thing we want to do is to create a prefab out of that so we can edit it pretty quickly and clean. So right click on assets and say create new folder and name it prefabs. And now just drag your player in the prefabs folder. And now just click on the arrow next to your player game object to edit the prefab. And under visual or player visual, create a new 3D object, which is going to be a cube for us. And we can just shrink it a bit to create a squared eye out of that. So place it anywhere you want just to have a clear visualization where your player is facing. I'm going to create 2 of them just to represent the eyes of our cube. And you can also apply some materials on them. So I'm going to do it here. So for the player, and let's do it for the eyes. Okay, it looks good to me. And now let's open up the player movement script. And in here we want to create a new function which is going to be responsible for our player rotation. And that function we can just call player rotation, so public void player rotation, and reference that function in the function where you're actually moving. So in our case it's the velocity movement, so we can reference it in there. So the first thing we need to do in the player rotation function is to get the velocity of our rigid body without the y-axis, because we want to calculate the y-axis and actually to rotate around that. So let's say vector 3, velocity without y equals new vector 3, rigid body.velocity.x, 0 float on the y-axis, and rigid body.velocity.z for the z-axis. And the next thing we need to do is to actually check if our velocity without y does not equal vector 3.0, so our player is moving. And if that's true, then we want to calculate our look rotation, so basically like the target rotation where we want to be rotated to, and for that we can use that line of code here. And after that, we want to calculate our new rotation, which is gonna be like the quaternion.lerp on the y-axis. So we want to lerp between our current rotation and the target rotation. And as you can see here, we're using the player configuration.turn speed, and we actually did not define yet what the turn speed is in the player configuration script. But just leave it like that, we're gonna fix it in a second. And now basically apply the new rotation on our rigid body. So let's say rigid body.move rotation and pass in the new rotation here. Okay, looks kind of good to me. And now let's open up the player configuration quickly and use the same scheme we used for the move speed for the turn speed. And now we can jump into Unity and click on the configuration game object and set the turn speed on whatever you want. Let's go with 10 here. Alright, so let's jump into the game and see what we have created here. Okay, so let's try to apply some movement here. And as we can see, we are actually facing the direction we're moving. Looks like it's kind of working, so let's try out the gamepad here. And also let's apply some movement on the stick, and we see it's working pretty fine. Okay, so let's start to work on the air logics here. Create these scripts in that specific folders, and once you've done this, open up the state super air. The state super air is basically the same as the state super ground, but only for the not grounded substates. Means you can define different substates once we are not grounded or we are in air, basically. For now, I'm just going to get rid of the moment behavior and replace it with state manager, and also create our constructor here, which is the same as we used to create before. Okay, so just leave it like that for now and open up the state sub in air and inherit from the state super air. And also create the constructor here. And that should be it for now. We will come back to that later. Open up the state sub jump and inherit from the state super air, and also create the constructor here. Okay, so let's begin pretty simple here. Once we enter the jump state, I'm just going to call it jump state so don't get confused here. So once we enter that, we want to kind of apply a jump on the y-axis. And a jump on the y-axis is basically a move. And for moving the player, or actually creating functions for moving the player, we use the player movement script. So open it up and create a function called public void velocity jump. And in there say rigid body.velocity equals vector 3.up multiply with player configuration.jump force. And just ignore the error here because we need to define the jump force in the player configuration script, but we're gonna fix it in a second. And also create a public float velocity y referencing to rigid body.velocity.y because we're gonna need later on, and actually pretty soon we're gonna work with that just to check if we are falling or jumping. So go to the player configuration script and create the jump force variable as you did with the others before. Once you've done this, open up the state sub jump. And in here we can write override and select enter. And remember, enter gets called immediately when we enter the state. And in the enter function, we want to call the velocity jump. So player.movement.velocity_jump. The problem right now, as you can see, is that we're going to be stuck in our state sub jump, and we need to fix that. So in the override update function, we need to check if our player.movement.velocity_y is less than 0. That means we are falling down. The rule here is actually pretty simple. So if you jump, velocity y increases, and if you're falling down, velocity y decreases. And that's why we are checking for less than 0 here. And if that's true, we want to change our state to in-air state. So StateMachine.change player.states.in-air_state. Now let's quickly jump into our state collection script, because we need actually to create our in-air state and the jump state. So open up your state collection, and in here say public state sub in-air and call it in-air state, and also get a public getter and a private setter here. And now let's quickly do it for our jump state. So public state sub jump and call it jump state, and also give it a public getter and a private setter. And now just basically create those states in the constructor of state collection. So say in-air state equals new state sub in-air, pass in the player general and the state machine, and do the same for the jump state. So jump state equals new state sub jump, and also pass in the player general and the state machine. And now we can jump back to our state sub jump, and as we can see, the error is now fixed. The problem right now is that we cannot check if we are grounded or not. Even if you land on the ground and our velocity y is 0, we can check for velocity y equals 0 and switch to the idle, but that's not an elegant and quite correct solution at this point. Instead, we need to work with collision detection here. So create a new script and name it player collision, and also go to your player prefab, and under collision create an empty game object called ground, and also open up the player collision script. So the player collision script is kind of like pretty much straightforward, and here we check for any collisions that can happen. So for each collision check, we create a header, and in this case it's the ground. We need a serialized field transform for our game object that we just created basically, a layer mask for ground detection, a distance to the ground, and a bool flag that is going to be responsible for the gizmos, so we can enable and disable that. Now let's create the physics raycast to actually detect our ground. So public bool ground and say physics.raycast, and now the ground check position, so basically from where we want to shoot our raycast from, and now like the direction in which our raycast goes, then the distance, or basically like the length of the raycast, and the ground layer. Also create the onDrawGizmos function, which is a Unity default one, and in here we can check if our flag, so the ground gizmos, is true, so it's checked. Then we want to draw our gizmos basically. If you're grounded, the color of the ray becomes green, and if not, it's red. Open up our player general and create a serialized field for player collision, and also create a public getter for that. Now go back to the state sub in air and say override update. And in here we want to check if we're grounded, so player collision.ground. And in here we can do some more advanced logic by checking if we have input while become grounded, or if there is no input actually. So if the length of our normal input vector equals 0, means we have absolutely no input, because otherwise the length of a vector wouldn't be 0, like the magnitude wouldn't be 0, and then we want to switch to the idle. Otherwise, as said, if magnitude is not 0, then we want to switch to the move state. Now let's apply our collision detection to the super state ground. So open it up, and in the update function check if we are not grounded, so not player collision ground. And if that's true, we want to switch to the in-air state, so we are falling. Let's get back to Unity and configure our player collision script we just created. Select the collision game object and add component, player collision. And here drag the ground game object into the ground check, and also create a new layer, which is going to be ground. To add a new layer, go to the top right corner, click on add layer and call it ground. And now click your ground game object and set the layer to ground. Now go back to the collision game object. In the player collision inspector, also set the ground layer to ground and enable the ground gizmos. We can change our ground distance here. So for me, minus 1.15 fits quite good. And if it's green, it means you are grounded. red means you're not grounded. So just search for a value that kind of fits quite well for you and leave it like that. And I'll select the controls GeoObject and also reference our collision script here. Alright, so let's start the game and see what we actually created here. For that, just drag the player a bit up on the y-axis and pay attention on the state text in the left corner. So let's start the game, and we are in the sub air state, and once we're grounded, we are in the idle state. Alright, looks good. So currently our jump is not working yet because we didn't create any input for that and we didn't apply any logic to switch to the jump state. So let's quickly do it. Open up the input actions that we called input system and create a new action here. Name it jump and make sure the action type is set to button and state check is off. Add a new binding here, select keyboard and mouse and click on listen. Now bind the key you want to jump with, so I'm going with space here and do the same for the gamepad. So create a new binding, select gamepad in this case, click on path, listen and press the button you want to jump with. Okay, so Unity's input system doesn't really support something like the default input.getKeyDown. But that's what you actually want when it comes to jumping, or any case where the button should be registered only once when pressing it. I've tried several things out and one pretty interesting mechanic worked pretty fine and actually solved the issue here. So we will go with the float value for the jump registration. That sounds pretty weird, but let me show you what it actually does. So let's open up the input processor and create a float input jump and a public getter for that. Now create a new function that we're gonna name process input jump and the float value parameter. And in there you set our current input jump to the value, so this.inputJump equals value. Open up the input manager and create a new function, public void input jump, input action.callbackContext, and then here we say if context.started, so if we started to press our button, and if that's true, we're gonna get the context.time. And put that in a float time. And also make sure you cast a float in here because context.time data type is double and we just want to turn it into a float. So once we got our time, we want to pass it to our input processor. So player.inputProcessor.process input jump time. Okay, now let's do the logic for switching to our jump state, and for that we will open up the state super ground because we want to be able to jump in idle as well as the movement state. So here in the update, say if player.collision.ground and player.inputProcessor.input is bigger than time.time. So what's actually happening here is pretty much interesting. Our input jump is always slightly larger than time.time. And if we kind of like tap out in our game and then we try to jump, and that kind of leads to an infinite jumping. So we don't want that. And because of that, we need to tell our player, or actually our input processor, to process input jump to 0. So we reset it back to 0. So player.inputProcessor.process input jump 0. And then actually switch to the jump state. So StateMachine.change player.state.jumpState. Okay, so let's get back to Unity and let's test out our jumping. But before doing that, we need to reference our new function to our input system. So click on this input GeoObject, go to player input, open up events, open up your general input, and then here click on the plus icon next to the jump callback context function you just created, and drag in the input manager, and in here the function you just created, input jump. Okay, and now just set our jump force in the controls GeoObject, so let's put it to 10. Okay, and now let's start the game and see what happens. Okay, so once we're started, we see we are in the air state, and once we're grounded, we are in the idle state. Now we apply some movement here, it's working, and now let's press the jump key. Okay, it works, and also with the gamepad, I press jump key, and yep, works pretty fine. So the first thing we want to create is a new movement control. So in your player movement script, copy and paste that function in, and that function is basically responsible for moving in air while not manipulating the y-axis on your movement. So think about what state is fully controlling our sub-air states, means which state is controlling our jump and in air. And you're probably right about that, that's the state super air. And now open it up and in there say override and select the fixed update because our movement is physics based. And type in player.movement.velocity movement in air player.inputProcessor.input vector normal. So we can still control our player while being in air. Another thing that I don't like is the speed of our jump, so kind of like the gravity thing. If you don't want to do that, just skip to the next section, but if you're still interested in that, here's how you can fix that. Open up the state sub jump, and in enter we want to tell our player to change the physics.gravity. So physics.gravity equals vector3.up, because that's the y-axis, multiply with minus 80. You can use any other value here, but 80 works pretty fine. And now open up the state sub in air, and in here we want to override the exit function and tell our gravity to become normal again once we are grounded. So physics.gravity equals vector3.up and multiplied with the default value, which is minus 9.81 float. If you actually change the gravity at that point, as I did, and you jump into the game, you will notice there's something weird happening when you try to jump. It's like an instant drag to the ground. What we need to do here is we need to increase our jump force by a little bit. So let's stop the game here and go to the config game object, and in here increase the jump force. So I'm gonna go with 30. So let's jump back into the game and press the jump key. Okay, looks very nice, very solid. And if you want, you can play around with the jump force value and also the gravity value, which is in the state sub jump. But I'm actually very happy with this one, so I'm gonna leave it like that. Alright, so here's a short recap of our current state machine. We have two superstates, the superstate ground and superstate air. And in both of them are different logics. So idle and move inherit from the superstate ground. So everything that is in the update of our superstate ground also will be performed in idle and the move state. And the same goes for the in air and jump state. So everything that is in superstate air is also getting called in air and jump state, just because of the hierarchy we created. If you have any questions regarding the state machine or anything else, feel free to use the comment section down below, and in the next episode we will work on the interaction state, so we can interact with any object that is interactable by just calling one function. Okay, see you in the next video.